Hi, my name is April Adkins and I teach chemistry to juniors during 6th period. You guys are going to get an activity sheet for today. Don't put your Chromebooks too far away. You are going to need them at the end of class. But to start with, you're going to get an activity sheet. And I need you to work at your table to create an investigation. The unit that we are currently working on involves searching for life in places other than Earth and learning about the chemistry of life on Earth as a means to complete that search. Usually when we do an investigation, I give you a piece of paper and it says do this, then do that, then do this, then do that, then do this, then do that. You're going to write the do this and do that. All right? So here's what you have available to you. You have deionized water, you have conductivity testers and batteries, you have baking soda, you have table salt, and you have borax. Okay? Baking soda, table salt, and borax are all 3 ionic solids. Okay? And I need to clear up a little vocabulary because on this paper it says salt A, salt B, and salt C. That is because all ionic solids are called salts. Your table salt is the one that you shake onto your French fries. Is that the same stuff that they shake onto the road when it's snowing? No, it's different, right? We still call that salting the road though, right? Okay, so you understand that ionic solids are called salts even though they're not all table salt. So you have table salt, borax, and baking soda. Those are the 3 things you have. You have deionized water, you have a conductivity tester, and you have a battery. And you get 6 minutes to work as a group to figure out how to test the conductivity of those 3 things. All of our lessons are technically project-based learning. I do no multiple choice assessments. All of our assessments are create or generate some sort of product or response. All right, stop.
Collaborate and listen.
Thanks. All right, stop.
Collaborate and listen.
Thanks. All right, so here's a couple things I want to say before we get started. 1, I'm trying to reduce waste. So let's try to not use a bunch of stuff that we don't need. I have a beaker of distilled water for you so that you're not getting it from the carboy and making a mess on the floor. So get your water from this beaker. I have containers that have table salt, baking soda, and borax in them. You've got some small beakers to use. You have conductivity testers, and the batteries are out of them. So when you're done with them, please take the batteries back out of them. Well, also, one more thing for you to know. If you get the little blue box wet when you're testing the conductivity of things, then you will get incorrect, inaccurate results after that because your solution will be stuck up there in a little blue box. So when you're getting solution, you only really need these electrodes in there. So see how much water you need? Just a tiny little bit in the bottom for that to be in solution. You don't want it far enough that it gets up on the green circuit board. Does that make sense? All right, so you're going to have about 10 minutes to do your investigation, which means you need to hurry and get your supplies and get going. Ready, set, go. It is a lot of planning. It takes a lot of work in the foreground to get ready for project-based learning. Most of the work is before the unit is actually launched. During the instruction, I do much less work than I used to do. The students do the work primarily during the instruction, but all of that work has to be laid before we get started.
I'm Sydney Leuenberger and I'm in Miss Adkins' 6th period chemistry class. Right now we are dissolving salt, baking soda, and borax into water to see if it has positive or negative or no charge. This year in science we've done a lot more labs and have done a lot more projects in that class instead of just doing like the teacher teaching you. We're like doing it our own. This is beneficial to me because it's not like spoon fed to me and we get to figure it out on our own.
My students are engaged almost 100%. I actually had a teacher say to me today about a particular student that if I had managed to get that student engaged, I must be doing something right. which tells me that project-based learning is a big difference from the past when I would have most of my students engaged, some really engaged, some really disengaged, and at this point, almost all of my students are engaged in the unit.